Okay, you guys, welcome back. Today we're talking about a really important lesson. It's probably one of the more challenging ones in this course, but it's really interesting, and I think that whenever we do enough examples, we'll be able to get it down, okay? So let's start off with a sketch real quick. With a sketch. Okay? Let's take a look at our X, Y, Z plane, okay? This is X, this is Y, this is Z, okay? And say we're going to consider a point. Let's put it right here. Let's call it X, Y, Z, okay? And this is going to become our spherical coordinates, okay? And it order is like this, rho, okay? Theta and phi, okay? Now notice in your book and in a lot of other sources, they like to do, instead of phi, the lowercase phi. For my handwriting, phi looks way too close to rho. I know that phi kind of looks like theta, but my phi's end up looking so much like my rhos that they're pretty, it's better for me to use phi instead of phi, okay? So I'm gonna use this, and your book uses this notation. So just take note of that, okay? The rag here, which I think is gonna do a better job of erasing than last time. Okay. Now, let's draw a line here from this point to my origin, okay? This phi, I'm gonna call the angle from the positive z-axis to this line, okay? The length of this line is gonna be this rho, okay? It's kind of like r from before, but a little bit different, because let's draw this down to here, make a right angle, and draw it back over to the origin. This is my projection of the xy plane. This is what I'm going to call r, okay? Do I have everything? Yes. Oh, one more thing. So just as before, the angle to this r, we're going to call this theta, just like we did before, okay? So let me write this out. Rho is going to be the distance from the origin to our point, okay? And notice that rho, like r, is going to be strictly greater than or equal to 0, okay? Theta is same as before, so same as in polar and cylindrical coordinates. Okay? And let's let theta run between 0 and 2 pi, because we know that we can just continuously wrap around and it'll be the exact same angle, okay? Now phi, this is going to be the angle, like I said, between the positive z-axis, let's read that, positive z-axis, and our line extending from the origin, make sure I'm not blocking this, to our point. Okay, and that's that line whose length is rho, okay? And let's note that we're going to put phi in between 0 and pi, okay? This was going to be restricted too. So it can run all the way from the top of the z-axis all the way down to pi here, okay? But no further. All right. So let's talk about some conversions, okay? And let's look at some geometry. I want to keep this picture. Let's delete as much as we can over here. Maybe I can fit it right over here. Let's see. Okay. I want to talk about going from, so conversions. Let's go from spherical coordinates over to cylindrical coordinates, which we talked about last time. Okay? So say that we're given rho, theta, phi, and we want, what is this? R, theta, z. That's my cylindrical coordinates, right? Okay. Well, if we were to look dead on at this triangle here, okay, where R would be our base, okay, so we're kind of looking over from the side here, we would have this picture. My base of my triangle is going to be R, okay? This length here is Z. I forgot to mark that, okay, because this is the height on the Z axis, okay? So we're going to call this bit of the triangle Z. Okay, R is the distance to that point Z right here. Okay. My radius of this triangle, or sorry, the hypotenuse of this triangle is going to be rho here. This marker's dying on me. Rho. Okay, now if this angle here is phi, then by some geometry, I can say that this is also phi, right? Okay. So, now that you guys can see where I got this triangle from this picture, I'll erase this, okay? Okay, so if I look over here, I can say that sine of phi would be R over rho, right? So let's write that. Sine of phi is R over, or sorry, excuse me, R over rho. Correct? What else can I say? I can say that cosine of phi, what is that? It's going to be Z over rho. Okay? So from there, I can write, let's look at this one. This says that R is rho sine of phi. And this one says that Z is rho cosine of phi. Okay? These are important. What else can I say from this triangle? One more thing, I could say that R squared plus Z squared equals rho squared. So how about I say that? Rho squared equals R squared plus Z squared. Okay? That's what I get. Now, I just went from spherical to cylindrical. Say that I want to take it all the way to Cartesian, okay? Well, this is what I need to take it there. Let me erase this over here. Okay, separate this. Well, let's just take the work that we just did and let's expand upon it, okay? So let's recall. We know that x is r cosine of theta, correct? And I know that y is r sine of theta, correct? Okay, and z is just z. This is for cylindrical coordinates. Okay, so we have this, let's just plug it. What do I get? X is, if x is r cosine of theta, and r is this, then I just plug that in. Rho sine of phi, cosine of theta, okay? Similarly, y, if that's r sine of theta, and r is right there, rho sine of phi, sine of theta, okay? And what is z? Well, z is just z here, but I actually know what z is in spherical coordinates, which is rho cosine of phi, okay? And finally, I can say that rho squared equals, well, if it's r squared plus z squared, but x squared plus y squared equals r squared, then I can say that r squared looks like x squared plus y squared, and then I just have my z squared, okay? Make that look a little darker. Z squared. Okay, so this is what I have in Cartesian coordinates, okay? So let's do some examples of switching around coordinates, all right? give this an erase. Let's keep all this if we can. Okay. Let's work over here. Let's do an example. Oh yeah, that's much darker. Okay, convert. What do I have? Square root of 6, pi over 4, square root of 2. And I want to convert this from cylindrical, so it's given to me in cylindrical coordinates, cylindrical to spherical. And I'll often abbreviate, just like I do cylindrical, I'll do an SPH for spherical coordinates. Okay? So, solution. Let's keep, I think that'll be okay. So, solution. Okay, we're going from cylindrical to spherical. So, theta stays the same. So, theta equals theta. What is this form? I'm in cylindrical, so this is r, theta, and z, okay? So theta stays the same, so theta equals pi over 4. Already got that one, okay? What about rho? Well, I know from right here that rho squared is r squared plus z squared, and I'm given those things. So rho squared is going to be, and let's just already take the square root. Skip one step. So r squared is going to be 6. Plus z squared is going to be 2. So what is this? The square root of 8, which is square root of 4 times square root of 2, so that's 2 root 2. Correct? Beautiful. Okay, so I'll write that. Rho equals 2 root 2. Perfect. Okay, what's left? We need phi, correct? Well, I could get phi from either one of these equations, okay, r and z. Sometimes one is easier than the other, but for the most part, they're usually pretty much the same in the amount of work that you do. So I'll do both, just to show you guys. Eraser. If I have to rewrite this part, I will. Let's move over here. And I kind of want to stay away from this far edge. Okay. Well, from here, I can see that r equals rho sine of phi. Okay? So sine of phi. What does that equal? I would just divide that over. That'd be r over phi. Okay? Or sine of phi equals, what is r? Square root of 6. What is rho? I just found it. Is 2 root 2. Okay? Yes. Now, from right here, this doesn't look very familiar to me, but let's see if we can work this. How about I multiply by the square root of 2 over the square root of 2? What would this give me? This would be the square root of 12. This would be, these guys would cancel each other out to just give me 2. The square roots will cancel. And so this is just 2 times 2, so this is 4. What does this equal? This is like 4 times 3 underneath the square roots. This could be 2 root 3 over 4, which equals what? Root 3 over 2. Now that looks familiar. Okay, so I have sine of phi equals root 3 over 2. Thus, phi is going to give me pi over 3. And remember that we're restricted from 0 to pi. Okay, so I just get that one value. Okay? Like I said, we're already there, but if I wanted to make sure that I didn't make a mistake here, so cosine of phi equals, or sorry, let's do, okay, z equals rho cosine of phi, okay? So dividing this over, I get cosine of phi equals z over rho, okay? So cosine of phi equals, what is z? Square root of 2 divided by phi. I'm sorry, rho, which is 2 root 2. I'm sorry, I don't know what I just did. These guys cancel to give me 1/2, so phi is pi over 3. Ready to melt down. Okay, so I can say that my point is